In this video, we're going to talk about constructing a confidence interval to estimate a population proportion. So what type of data do we make a confidence interval for proportions? The answer will be categorical variables. We need to set up as a binary data, which means there's only two outcomes, success or failure. We summarize the data by sample proportion of the success and construct a confidence interval for the population proportion. To find the 95% confidence interval for a population proportion, we need to know standard error. Standard error is an estimated standard deviation of a sampling distribution. This is denoted as SE for standard error. We previously learned that the standard deviation of the sampling distribution of the sample proportion was sigma p equal square root of the ratio between p times y minus p and n. The n will be sample size. However, the population proportion is generally not known, so we have to use the p hat instead of p. So the standard error will be calculated in this way. Note that we use the p hat instead of p. This equation estimates of how much variation there can be between the different possible sample proportions. Remember, our standards for assuming the sampling distribution of the sample proportions are the following. We have to check both conditions before we assume p hat follows normal distribution. What's more, data has to be randomly obtained so we can assume the p hat follows normal distribution. After we check this part and this part, we can use the formula for the 95% confidence interval for the population proportion. Note that the estimated standard error is calculated in this way. The theoretical confidence interval is represented by the blue shaded area. The p is the population proportion, and this length is defined as the margin of error. So from this point to this point is the theoretical confidence interval. However, the estimated confidence interval, or the actual confidence interval we will get, is calculated by the sample proportion p hat plus or minus the z critical value times the estimated SE.